My name is Paul. I work as a lead developer in Simplemeter. One of our products is a water stream, a Kafka native MQTT broker. So I wanted to talk about the overview of Kafka and IoT and how to make them work together. So this is our agenda. What is Kafka, for those who may not be aware? What is MQTT? Why integrate them? How to integrate them? And more details about our approach to integration. If you have any questions, don't hesitate to interrupt me and ask them before you forget them. Okay, so Kafka, in case you don't know, is basically a distributed log which keeps messages in order, let them be processed by multiple systems independently, reprocessed again as needed. It has a rich tool set for integration with different data stores, different processing systems. So it's a nice central point for integration in your enterprise. On the other side, it doesn't work very well immediately with Internet of Things because of some reasons. For example, protocol has too much overhead for small messages. It's not well designed for a slow and unstable network when devices are constantly dropping connection and reconnecting again. It doesn't maintain sessions for individual devices. So, for example, if you subscribe to some topics, drop the connection and connect it again, you're going to need to resubscribe to all these topics, which means more traffic and more time. It lacks some IoT-specific features, such as last will. When the broker reports if a device is down. MQTT is a messaging protocol. It was originally designed for gathering telemetry for the oil pipeline in a remote desert. With the only available connection is a satellite link, which was expensive and unstable. So it was ground up designed to be lightweight and fault tolerant. For now, the most popular version is 3.1.1, but there is version 5 also available, which mostly adds better metadata, more transparency, and so on. So why use MQTT protocol? Because it's the most popular protocol for connecting IoT devices nowadays. It has nice features like last will that I mentioned before, when the broker reports if device is down. Retained messages, when some devices may not be sending a message very often, and they can tell some message to be kind of background message, so that if subscriber subscribes to the topic, it immediately receives this message without waiting of the next updates. It supports flexible quality of service levels, which let you balance delivery guarantees versus speed, ranging from at most ones to exactly ones guarantees. MQTT can talk over WebSockets, so you can also connect your web applications through it. And MQTT brokers are usually designed to support a large number of client connections. It's not a silver bullet either. So, for example, MQTT brokers usually don't have reprocessing of historical data. They don't store. They don't let you store the data arbitrarily alone. And So you cannot reprocess your data, and it is expected that consumers consume data that consumers consume data that is being produced right now, or at least recently. It doesn't have transaction support, so it suits better as the entry point to your system rather than the central integration point. To recap the differences between Kafka and typical MQTT brokers, Kafka lets you configure storage time for whatever you want. It supports asynchronous processing when consumer and producer are not expected to be alive at the same time. It supports reprocessing of the data. It has a rich toolset for integrating with different databases. On the downside, it's too heavyweight for small devices to talk with it, and it doesn't maintain the session for individual devices. For the MQTT brokers, advantages are that their protocol is more lightweight. It works well with unstable connection. It has handy IoT features like last will and retained message. Uh, they well suit handling of a lot of clients at the same time. On the downside, there is no reprocessing, uh, and it's expected that the consumers are alive at the same time as the producers, and there are no transactions. Oh, why would you want to integrate them? Uh, let's imagine the first scenario. If you have a lot of systems where you want to stream your IoT data, in this case, MQTT protocol can serve as an entry point, a device-friendly entry point, and Kafka can serve as a distribution hub, and which streams data to different applications and using Kafka Connect plugins to different databases. If you're not aware, Kafka Connect is yet another tool. It's a separately deployed cluster, which has a rich set of plugins talking to very, very different databases. Another scenario when you may benefit from integrating MQTT and Kafka is if you have Kafka Streams applications or KSQL DB deployed somewhere, which you may use to aggregate, filter, and transform data gathered from IoT devices, and transform this into commands that they send back to these devices. With KSQL DB, you can create a SQL-like query, which does this even without programming. And what are the options available for integration? The first option would be using this Kafka Connect and source and sync plugins for MQTT. This works with any MQTT broker. So if you already have MQTT broker in place, you will not need to change it. On the downsides, it has a lot of moving parts. Besides MQTT broker and Kafka, you also need a Kafka Connect cluster, and it is prone to message loops if configured improperly. That is, MQTT message may be mapped to Kafka message, then travel back to MQTT broker, and so on. Yeah, and official Confluent source and sync plugins for MQTT are commercial. Another option is to use Confluent MQTT Proxy. This is kind of half broker. It can only stream data from devices to Kafka, not vice versa. This is obviously the downside. On the of the benefits is that it does not require a separate persistence, so it's easy to scale. If you want to support more devices, you just spawn more proxies, more MQTT proxies behind the load balancer, and you got more devices handled. So this is a kind of step in the direction of Kafka native MQTT broker. That is, it doesn't require a persistence on its own. It uses Kafka as its only persistence. A third option is to use a vendor-specific Kafka plugins. Some MQTT brokers, for example, HiveMQ, provide plugins which let you connect it to Kafka. That, of course, requires support in your broker, so not all MQTT brokers will work with this. And you still need to maintain two persistent storages, one for Kafka and one for MQTT brokers, which may sometimes complicate scaling. Hello? Anybody ask something? Okay. Which may complicate scaling of the MQTT broker. And fourth option is to use a Kafka native MQTT broker, such as such as WaterStream developed by us. It uses Kafka as its only storage, so it's easy to scale. And in scenarios when your device needs to talk to Kafka, you're going to get the best latency because it delivers the message from device into Kafka with minimal overhead. On the downsides, it may not show as good latency if you need your devices talking to each other through Kafka broker, because the message needs to travel to Kafka and back to get into another device. As an example of Kafka native broker, we have developed WaterStream. It's fully featured MQTT broker. It supports all features of MQTT 3, and soon it will support all the features of MQTT 5. It doesn't need any additional persistence, just Kafka, so it's easy to scale. We've actually tested it on 12 two-cores machines, handling 1 million clients. And now a bit about how it's built inside. So it has a network layer based on Netty MQTT plugin. By the way, we have contributed MQTT 5 support to this Netty plugin. It maintains a session per each MQTT client, and session maintains its state, such as subscriptions, state of messages that need delivery guarantees, such as at least once or exactly once. And whenever some update to session is made, it produces a message which is stored to a specific to a special topic intended for session persistence. And each WaterStream node runs a Kafka Streams application, and they shard the load between each others. So whenever a client drops the connection and reconnects, it can connect to any WaterStream node, and that water stream node where it connects will use this Kafka Streams application to find the node where the actual session state is stored and pick the latest snapshot from there. So this is how we do persistence in Kafka. And there may be one or many message topics where actual MQTT messages are stored. MQTT topic becomes the key of the message, and the payload becomes the body of the message. Why not map MQTT topic to Kafka topic one-to-one? That's because MQTT topics have much wider set of supported characters. A lot of these characters, which are allowed in MQTT topics, are forbidden in Kafka topics. So we map it to the key instead of Kafka topic. And there are rules available for mapping additional Kafka topics if you want to. So in a nutshell, this is how it works. You can check out the demo, which demonstrates both processing of the data with KSQLDB and using MQTT through WebSockets to get the data into the browser. And of course, you can read the documentation. Thank you for your attention. This is basically all I wanted to say. If you have any questions or comments, we can discuss them now.
Guys, now is the time to ask questions. If you want to open your microphones and video, please feel free. Okay, Paul, if no one wants to ask, perhaps a quick summary.
Can I?
Yep.
Yes, please.
I just wanted to ask a question, just out of curiosity. How did you manage semantic delivery in your water stream use case?
Semantic delivery? What do you understand as semantic delivery?
I mean, exactly once, at least once. How did you configure your MQTT, or could you elaborate?
We store the state of the message into the session, and if the client keeps the connection, it's pretty easy. We take this information from from the session. If a client drops the connection and reconnects again, we again use this Kafka Streams applications to load the session state, which knows what is the situation with message transmission. That answers your question, or you meant something else?
Yes. So basically, the consistency is completely demanded to Kafka Streams, to the Kafka Streams job that is running.
Yeah.
Okay.
We also have a subsystem. Of course, Kafka Streams have its limitations because it's eventual consistent, but we can alleviate it greatly by having a component which checks what is the latest offset of the session topic, which Kafka Streams application has seen. And if client reconnects at a later point, first we check what's the latest offset at that point and wait for a certain period of time until Kafka Streams application reads something at this offset or something after it. this way, if we have enough updates in the session, and WaterStream nodes do not restart often, we can ensure that the device sees the latest updates it has written in the previous connection.
Okay, okay. Thank you. It's clear. It's clear now. Thank you.
You're welcome.
Anyone else, please? Now is the time. Perhaps, Paul, if you could put the slide of your email again, contact information,
Sure.
should anyone would like to contact you directly.
Okay. Sure, I will add this and then send you the presentation. So, anything else?
No, let's wrap it up. I will be sure to send the community this video and the PowerPoint. I would like to take this opportunity to thank you for taking the time to prepare this lecture and educate us. It was a pleasure. You're more than welcome to lecture here again as much as you like.
Thank you. Thank you for the opportunity to present it. Thank you everybody for attention. So bye everyone.
Bye. Good day.
Bye. Thank you.